So we left it last time with we were able to call native functions from Lua using the runtime type information that we'd registered. We registered a few really basic functions here that had no parameters and no return types, and with just a little bit of binding in Lua we were able to register those. We registered this call global from Lua method and we were able to invoke it there, but we weren't able to pass any parameters to these functions because it wouldn't we didn't actually try it, but it wouldn't work here because we're not passing the parameters along. So we could test that by just modifying one of these functions here, and let's just pass a couple of parameters along to this hello world 3, and let's see if we can, well, let's see what happens when we call that. So hello world 3 is just one of the functions that we've registered. So let's just make it print out this x and y that we're passing along. So the good thing about the RTTR and the registration for this is that even though I've added some or changed some parameters to this registration down here doesn't change, because all we have to do is pass it in the pointer to the function and it knows how to register all the parameters. So it means that we don't have to mess about with that if we're just changing code like you'd be doing in a normal life cycle of a program, just adding parameters and removing them, changing the signatures of functions. So let's see what happens when we run that. So hello world 3 just didn't get called. We didn't get any errors, but hello world 3 didn't get called. And I believe the reason for that is the RTTR library doesn't throw exceptions according to the documentation. It doesn't throw exceptions. Let me just move this window across here. So this invoke method, I don't know if I can find the correct one. The invoke method will not throw an exception, but it will return a variant that there it is. So the arguments have to be the exact type. Otherwise, the method cannot be invoked. An invalid variant object, see variant is valid, will be returned. So what's going on there is hello world 3 isn't getting called because we're invoking it incorrectly here. So we should actually, first thing we should do is get the result, and we should just assert that it is valid. We could do is valid. There we go. So this should always be valid even if there's no return type. That's what it's telling us anyway. So if it's not valid, then we'll assert, we'll assert there, and we'll just print out what's wrong. We were unable to invoke, what were we unable to invoke? Method to invoke, and we can get the name of that, I think it's toString. It's a bit of a long call this, but this is technically only debug code, so we're okay there. So unable to invoke this method. So at least at this point, with this, we should be able to see what's wrong if we've done something wrong. Unable to invoke hello world 3, there you go. So we don't know why, but we were definitely unable to invoke it. So that's at least a start. Let me just bold that. There we go. So that's a start. We know something's wrong because we've added some parameters here and we didn't call the function correctly. So what we want to do is we want to work out what these parameters are and pass them along to this invoke. And the invoke, if I look in the documentation, these invokes are have these arguments that you pass along. So we could use that, but we don't exactly know how many arguments there's going to be, and it could be any number of arguments depending on what the function's doing. So there is actually, I think there's an invoke variadic which just takes a vector of arguments, and I think that's the one we want, because we're going to pull all the arguments from Lua, and then we're going to pass them along inside this vector. So it wants RTTR arguments. argument. There we go. So these are the native args. So we want to call this invoke variadic, and we're going to pass along the native args. So that's how we're going to invoke the function. This should still behave exactly the same, I think. Yeah, so exactly the same, but we're just calling a different version of the function. So what we need to do really now is we need to populate this vector of arguments with the arguments that were passed from Lua. So one of the first things we're going to need to find out is how many arguments has Lua passed us for this function. And we can check that against the number of arguments which this method to invoke says it has, because the runtime type information knows how many arguments there are. And we can assert that that's okay as well, in case we're passing the wrong number of arguments. So to get the number of arguments, so let's get the number of Lua args. We can actually just do Lua get top. And what that does is just, that just gets the index for the top of the stack. And in Lua's case, because it's indexed from 1, the top of the stack is going to be like, if there's 3 parameters passed, the first parameter will be indexed 1, the second parameter will be 2, and the third parameter will be 3. So the top of the stack is actually the number of args that have been passed along. So in this case, yeah, if we just get top, that actually is the index at the top of the stack, but it's also actually the number of args that have been passed. So we know how many arguments have been passed. How many native args does this function actually want? And according to the docs, we do method to invoke get parameter infos. So there we go. And what have we got on that? That's got that has a size, I think. Yeah. Actually, I'll pull that out into a separate parameter for now, because we're probably going to need this parameter infos again in a minute to be able to call the information. And this returns, depending on how you compile it, this is returning an array range of RTTR parameter infos. So these are the native params. So that's our basic, yeah, that's our array of information about the parameters that this function takes. And the number of native arguments is just the size of that array. So we know the number of Lua args that were passed, and we know the number of native args that we're expecting to be able to call for this. What we could do now is do another assert that if the number of Lua args is not equal to the number of native args, then we can do another assert. And the actual assert would be that these two need to be the same for this function to be able to call successfully. And let's print out an error message. It would be error calling native function, and it would be the same thing we did down here. That's the name of the function. It's a bit wordy, but there it is. So error calling native function, wrong number of params, or let's call them arguments. We expected this many and we got this many. So we expected the number of native args, but we actually got the number of Lua args. So we'll get an error now, hopefully, if this works. We'll get an error if we're passing in the wrong number of parameters. We've got I'm going to cast that to an int. I'm fine with that being an int. Let's see what we get. So error calling native function 3, wrong number of args, expected 2, but we got 0. So that looks like that's working because we haven't actually passed the correct number of arguments along. So all we've really done is we've added just more error checking to see that we're actually calling this thing correctly. And as you can see here, we're not, because we're calling hello world 3, but our hello world has 2 parameters now. So in our case, depending on how you want to handle it in your binding, you could get it to, you know, just ignore this call or whatever. But I think in this case, this is an error because this just function can't be called correctly. So the rest of the program from this point on, or the rest of the script, would technically be invalid because this isn't working correctly. So let's just pass a couple of dummy parameters along. Just 2 different parameters, and let's see what we get. So we should get past the first assert, but we're still on the second one because we didn't actually populate the parameters in this native args. So we didn't actually populate the ones that we wanted to send along. So first thing I'm going to do is just initialize this vector to be the size of the number of native args, because we now already know how many we've got to pass. So all that's doing is just initializing the array. And then what I need to do is start looking at the Lua arguments and then filling them into these arguments. So we probably want to do a loop round all the arguments that are there. So I'll just loop round I to I is less than so the number of Lua args, because there's 3 arguments that we want to, well, in this case there's 2 arguments in the case that we're trying to check that we go around. So that's just going to loop around the number of times for the number of arguments that we've got. For each one, we need the index of the Lua argument on the stack, and Lua stack is indexed from 1. So the argument index is actually I plus 1. I'm doing this for loop from 0 because it probably makes this slightly easier, but the actual Lua argument index is I plus 1. So the first parameter is at 1, second one's at 2. Then we could, I'm not sure if we've used this before, but there's a function called Lua type, and remember there's only like 8 Lua types, so we can just do Lua type on that argument index, and we can find out what it is. That just returns us an int for the type, and there's just a bunch of defines that tell us which one is which. So we're going to ask Lua for the type, we're going to find out what it is, and then we're going to switch on the type. So Lua type. If we don't know what the type is, we're going to assert. Don't know this type. And I think the Lua types are all, let me see, Lua, I think they're all Lua T something. Yeah, so we want Lua T number. So we want to find out when this is a number, we're going to handle the number case, because at the moment our native function's only got 2 numbers in it. So the problem we're going to have is that to call the native function, according to the RTTR docs, we have to pass in the exact correct type for the methods to invoke. So if it takes an int and a short, we've got to pass an int and a short. And if it takes a float and a double, we've got to pass a float and a double. If it takes 2 floats, we've got to pass 2 floats. The problem is Lua doesn't have any of these types. Lua just has number. So we're going to have to like switch on the number type, and we're going to have to find out what type the method is expecting. We're going to have to turn our number into the correct type that the native one is expecting. So what we need to do is, well as looping around these Lua args, we need to loop around the native args as well, because there should be a 1-to-1 match. If this function is going to be called correctly, for each Lua arg, we're expecting a native arg. So what we need to do is, we had our native parameters here. We can, let me see, we can get an iterator for those native parameters. So native params iterator. So that's going to iterate round, that's going to get the first native parameter, and we've got an iterator on that, and I'll increment that on each loop as well. So what we should have there is for each Lua arg, we've got a matching native parameter as well. So this is a, we can get the type of that, I think. Type, what would it be? So the native parameter type is this, we get the type? There we go. So yeah, so that's just going around, and it'll go around the first Lua argument. It will get the native parameter that we're expecting, and then it also looks at the type of the Lua parameter that was passed in. So we now know both pieces of information that we need to know. We've got our type, our native type, and we know the Lua type. So what we're going to do is when it's a number, I believe this is how you do it with this RTTR library, we can say if the native parameter type is, we can ask it, is it, well, in our case we've only got int at the moment, so let's just go for int. So we can say, is the native parameter that you were expecting for here, was it an int? And if it was, then we're cool with this, because what we can do then is get the number that was on the Lua stack, and then put it into our native args. So where's our native args? Here they are, native args. So it would be native args I, that's the parameter that we're working with. And now I'm going to show you how I did this initially and show you that it doesn't work. And this might be obvious to you, but it's certainly not clear, might not be clear what's going on. So we do Lua to number to get the number off the stack, and it is the Lua arg index is the one we're interested in. So technically, yeah, that works out that the parameter is an int, gets the number from Lua, casts it to an int, and then puts it into the native argument. So we have to cast it to the int because these native args are expecting it to be the correct type to work out what's going on. So when the invoke variadic down below happens, it knows exactly how to invoke that function correctly. So we can try this and we'll see that this doesn't work. I'll just run it and we'll see what happens. So it's actually called the function now. So it looks like we have passed the parameters along, but interestingly, you'll see instead of it getting 42.99, we've got 99.99, and that might be a little bit confusing. It's like, well, did we do something wrong in our loop? What happened here? And the problem is, yeah, if you look up here, we actually called it with 42.99. The problem is that these native args, this RTT argument is actually just a wrapper. It's kind of like it just keeps a pointer to the argument that you want to pass along. So when we did this Lua to number, it's actually putting this int on the C stack, and then it's taking a pointer to that, and then it's wrapping it into this argument that we're passing along. And then when the next iteration of the loop comes around, it does the same thing again, but the old parameter that was on the stack has now disappeared or been replaced with the other one, or you might just get random memory. So in our case, this kind of works, but it can't, because when we're passing by value like we are here, we're going to have to keep a reference to this Lua number, because it currently only exists on the stack and it's getting deleted by the time our invoke is happening down here. This int that we pulled from Lua is just gone. So what we're going to have to do is keep another vector of the actual values that we're passing by by value, sorry, and then store those and then pass those along. So hopefully that makes some sense to you. But what I'm going to do here, this is how I solved it this time. I mean, this might not be the greatest thing in the world, but I'm just going to show you that this is a way of solving this. So what I did was I created this, I just created an array, and this is where we're going to store the stuff that we get out of Lua, just temporarily until the function's been invoked, and then we can remove it. So I'll call this pass by value, and again we can initialize this with the number of native args, because we know we can't ever possibly need more than that. And I'll make our pass by value. I'm just going to make it a union pass by value. And in there we'll put our int value, and also in here you could have like short, well in fact you're going to have to like short value and etc. So what we're going to do, instead of just pushing that into the arguments, we're actually going to push it into this passed by value array first. So we'll put it into there. So that's storing our integer value in this little array. Remember, we've already initialized it with the correct size. We know we can't need any bigger, so we don't have to do a pushback or anything. We know this array's got a big enough size. And then we'll push that. So that'll take the pointer to this int value, and it'll be wrapped in this native args thing. So that, hopefully, is all we need to do to get this particular example working. So keep in mind, so the only difference now is that instead of this Lua number being on the stack, we're now storing in our little vector, and we're holding until that vector until invoke variadic is finished. So that's how we're getting around this problem. Hopefully, if this works. So there we go. We've got our 42.99 going on there. So that's all cool, but obviously this only works now with ints. So if we somehow, if we change one of these to a short like that, this thing's going to go wrong again. Let's just try that. So yeah, failed to invoke. And in this case, we probably could get some better debug output there as to, why it couldn't invoke. Was it line 61? So yeah, it was just unable to invoke it, and we didn't know why. Probably because we didn't fill these parameters correctly. I mean, so the one thing we could do here is insert there and just say unrecognized parameter. And we could even get the name, I believe, because we've got the type. Name. Again, it's a bit long-winded this, but so unrecognized parameter type. So that should give us a slightly better error output. Unrecognized parameter type short. So there you go. So that hello world 3 is not going to be able to be called because we haven't handled what happens if this number happens to be a short. So that, just put brackets around that just to make it a little easy to understand. So then really what you have to do is go through all the different number types that you want to handle. And if it's a short, we'll cast it to a short. So there's probably ways of cleaning this up, or doing some template magic or whatever you think you can do, but you'd have to handle all the number types here that you're passing by value and work out how to keep them while you're invoking the function. Let's just see if that works now. So there you go. So it's back to working again. So we can now call a function with any number of parameters. It doesn't have to be 2. And as you can see, 0 still works because it just does the array and then doesn't fill anything in. Any number of parameters will now be able to be called from Lua just by registering them. And if we happen to change this function, we pass another int along, we'll get our error output and it'll tell us that we're doing something wrong. So all we have to do now is change that function, and it's going to say, sorry, you've passed the wrong number of arguments. So that might happen if someone who works in the native code to change something, and then it will break the script. So at least we'll know why it's broken the script, so we can just pass another parameter there. So it only works with ints and shorts, but you could expand this to work with whatever you want. And there you go. So that is working. We're able to call, just by adding code to this function here, we're able to call stuff, and we're able to pass numbers by value from Lua into native code. And it wasn't the greatest deal of code in the world. I mean, this, again, I'm not saying this is the uber perfect way to do this, but it's just showing you what you would have to do to convert this thing. And you can see some of the problems with the difference between native and scripting is that our native code only has one number type, but C++ has 100. So we've got to do some kind of work to call these functions correctly so that the native type knows exactly what to do. And of course, we're not handling the return type yet either. All we're handling is the fact that we need to know that this was called correctly. So I hope that was of some interest, and I hope that makes some kind of sense that we've only written a little bit of code there, but we're now able to call any kind of function with any number of ints or shorts in parameters. I think that's really cool. You could probably think of ways to improve this code if you were actually looking at it, or you know, you could use some template magic or do something better than this. But this just proves the point of this is the kind of thing you're going to have to do to get runtime type information to be able to call this stuff. So next time we'll look at probably just getting the result back and sending that back to Lua. So then we can have a function that we can call with some numbers, and then we can get the result back, and we can start using that in real world code then. So we'll do that next time.